Okay, so this problem is missing a figure, so let's draw our figure in. And we have two charges, both on the y-axis. And one is at 6 meters, this is 6 meters, and we'll call this one Q1, we'll call this one Q2. And one is at -4, so this is -4 meters, and we'll call this one Q2. And so what we have to find is we want to find the point along here. Let's just call it P. And I'm not sure where it is. It's somewhere in between probably these two charges. And why do I think it's in between? And that's because one of the charges is, let's see, okay, so one of the charges, Q1, is, okay, so I got that wrong. Let's erase that. And Q1 is -9. So this one's Q1, and it's equal to -9 times 10 to the -6 coulombs. And this one is Q2, and this is -8 times 10 to the -6 coulombs. And so I also know here that the difference between these two, the distance between these two is 10 meters, 6 plus 4. Okay, so if I think about the field due to Q1, this is Q1, I'm going to be pointing towards the charge. And if I think about the field on Q2, I'm going to also be pointing towards the charge. So if I think about where on the, I'm going to be on the y-axis somewhere, because my charges are on the y-axis. So at some point P, these, my field should cancel out. And that would kind of make sense, because if this field here from the upper charge is pointing upwards, I have a field here that's pointing downwards. So it looks like I can find a spot along the y-axis in between these two charges where the field is going to equal 0. So I'm going to write E is equal to E1 plus E2 on the y-axis. All right, so if and I know that this E is going to equal 0 at that point, so E at point P is going to equal 0. So I'm going to put 0 is equal to, what's that, P? Now E1 is equal to K Q1 over R squared over R P1 squared, and plus K Q2 over R P2 squared. Okay, so now because this is equal to 0, I can cancel out, I have a K in both of these terms, so I can cancel it out and not worry about it. Okay, and now, so now I have 0 is equal to Q1 over R1 squared plus Q2 over R2 squared. All right, I'm going to substitute in here. I'm going to say that, my P, I'm going to call this distance from here to here X. And then that tells me the difference from here to here would be 10, the full distance, minus X. So this part right here is going to be 10 minus X. And that's what I'm going to plug in for my R's. 0 is equal to Q1 over, and so this one's going to be 10 minus X squared. And this one is going to be plus Q2 over X squared. And I notice that you probably might get confused with the fact that I'm using X here. X just means, hey, it's some number, and this is 10 minus that number. So I'm just using X as a placeholder for a number that I don't know yet. I'm not really using it to define a direction. Okay, so I want to keep going. So now I can work through, so I have 0 is equal to, let's erase that for a minute now, and set these two things equal to each other. Okay, so I have Q1 over 10 minus x squared. And now if I brought this to the other side, and so this is going to be a negative q2 over x squared. So what I did was I left this here, and then I brought this, I subtracted this from both sides and brought it over here. So that's how I got this equation. And now I want to cross multiply. So I'm going to say q1 times x squared is equal to a negative q2 times 10 minus x squared. Oops. I want that. Okay, so now I want to keep going. So q1 x squared is equal to a negative q2 times 10 squared. So I'm going to multiply 10 minus x times 10 minus x, and I get 100 minus 20x plus x squared. And that would be the binomial expansion. That's how we did that. Okay, and so now I want to work through, so I want to q1 x squared is equal to negative q2 times 100 plus, notice there's a negative and a negative, so that'd be plus 20 q2x minus q2x squared. So now I want to put the x squareds together. So I'm going to bring this q over here. I'm going to bring everything over here to this side. So I'm going to add q2x squared here, I'm going to subtract here, and I'm going to add here to bring it all to one side, and so that I can set the whole equation equal to 0. So that's going to be q1 plus q2, I'm factoring them out, times x squared. Notice this has a q1 times x squared, and when I bring this one over, I'll have plus q2 times x squared. Okay, minus 20 q2 times x and plus q2 times 100, and that's equal to 0. So now I can use the solution for the quadratic equation, and so remember that so x here is equal to a negative b plus or minus b squared minus 4ac over 2a. Now this is my, right here, this is my b, and it has a negative also, so that's my b. This right here is my a, and this right here is my c. So that's what I can plug in here. So I get x is equal to a negative here, negative b times a negative would give me a positive, so I get 20 times q2 plus or minus, and I get 20 q2 squared. I don't have to worry about the negative because I'm squaring it. Minus 4 times a, which is q1 plus q2, times qa and then c. So I have q2 times 100. And then that's all over 2a. So 2 times q1 plus q2. Okay, so now I'm going to move up a little bit. And I'm not going to work this out, but you'll find that x is equal to this positive 0.85 meters. Well, so that x should be equal to 4 plus 0.85. So I'm guessing when you solve this, you'll get x is equal to 4.85 meters. So that should equal 4.85 meters. That would be x, and then that would be the position, P. So that's what you would get, and you would then know that this would be my x. So this would be x from here to here to our point P, so it's going to be 4.85, and once we subtract off 4, we get to the x-axis, and so we know our position P would be at 0.85.